sorry, this is lesson 11.3 in pre-algebra, distance and midpoint formulas. Okay. Oh, man, I have to rewrite that? All right. So here's our coordinate plane. And, okay, if I want you to tell me the distance between that point and that point. You know, I just said, you know the distance between there and there is 3 because it's just 3 blocks, right? So it's 3. Whatever it is, it's 3. What about here, though? What about there? I mean, like it's going to be a little bit bigger than. Well, look here, right? So from here to here is 4, right? And you kind of move that thing up that direction. You know that it's going to be a little bit longer than that, right? Notice this. Here's how you can do it. You use the Pythagorean theorem. Well, wait a second. The Pythagorean theorem is used for when we have what shape?
Triangle.
Not any triangle. Right. A right triangle. Can you draw a right triangle here using this? Yeah, you can. You can go like this, and like this, and like this. And so all of a sudden now you have yourself a right triangle, and you know this distance is 4, this distance is 2, and this distance is what we're looking for. So can't you use the Pythagorean theorem to find the distance between any 2 points? Listen, there's that one. What if I wanted you to do this one? What if I wanted you to find me the distance between here and here? All of a sudden you go, oh my goodness, well, what do I do with that? Well, isn't that a triangle? And this is whatever this is 7, and this is 1, and this is x. Does that make sense? I don't care what the distance is. You can draw a right triangle on the coordinate plane. You can draw a right triangle. Does that make sense? So then you can use the Pythagorean theorem to solve this. Now, let's do it. Let's find the distance for this between these two, okay? So then all of a sudden, what's the Pythagorean theorem?
A squared plus B squared.
What's A?
4.
4 squared, could have been 2, right? Plus 2 squared equals x squared. 4 squared is 16 plus 4 equals x squared. 20 equals x squared. What do I do to get x by himself? Square root. X equals the square root of 20. Or you could say, what's that close to? That's either, it's in between what 2 numbers? 4 and 5, right? It's in between 4 and 5. So you'd say, if I said round to the nearest, what is the square root of 20?
The square root of 20.
What is the square root of 20 though? What is it? 4.47. So you round to the nearest tenth, it would be 4.5, right? 4.5 is the distance. And that should make some sense, because if this is 4, then the hypotenuse should be a little bit longer than the longest leg. Makes sense? So then there's that basic concept there that you need to know. There is a distance formula. There's actually a formula to use if you don't want to use the Pythagorean theorem. The formula looks like this. It's a little ugly, but it works. The distance formula is D equals square root of x2 minus x1 squared plus y2 minus y1 squared. That is the distance. Now listen, this is a very different and fancy way of writing the Pythagorean theorem. It's just, this is in the distance formula. Now here's the deal. Let's take our exact same question, which was here and here. And we wanted to know the distance there. Agreed? Okay. So then what is the coordinates of there? What's the coordinates?
-3, 2.
This is -3, 2. You should all know that. And what is this coordinate? 1, 4. Okay. We have to choose one of these points to be point 1 and one of them to be point 2. Let's just, I always do left to right. It doesn't really matter. Here's point 1 and here's point 2. Does that make sense? Are we all paying attention? Because I'm about to give you some of these and you're going to have to know how to do this. Okay, let's use the distance formula. So it would go D equals, okay, the square root of, big, huge square root, x2. Which one's x2?
1. Oh, wait, 1.
Okay, so listen. No, look. Inside of a... What goes here and what goes here? What letters?
X and Y.
This is x and y, right? So when I say x2, then here is the x and here is the y. Here is the x and here is the y. Which one's x2?
1.
1 is 1 minus, what is x1? Negative 3. 1 minus negative 3. We'll fix that in a second. Squared plus, what is y2? 4 minus y1?
2.
2 squared. Okay, let's do it again. D equals the square root of, what is 1? Okay, you see that? That should, the two negatives touching should instantly make you go, oh, right, that's plus. Right, Jay? Plus, so what is 1 plus 3? 4 squared. Plus, what is 4 minus 2?
2.
Plus 2 squared. Rewrite it. D equals square root of. That would be 16 plus 4, which is D equals the square root of 20. Do you remember that's what we got before when we did the Pythagorean theorem? Right? So this is just a different way of doing the Pythagorean theorem. This time you're using the points that are out there. Does that make sense? The reason why you want to do it that way sometimes is because what if I tell you, like here's this, and I give you this. What is the distance between here and here? And all of a sudden you're like, oh man, do you really want to count that? Or what if I made it bigger? What if I changed it to this? And I said, what's the distance between here and here? Suddenly, you're not going to want to do that counting, are you?
No.
Are you going to want to do that counting? No, you might make a mistake in the counting. But what if I told you that this is point negative 2, 13, and this is, you see, all of a sudden now, which one are you going to use?
The formula.
The distance formula. Do you understand what I'm saying? It just depends. You want to know how to use both. So I'm going to let you guys do one. Okay, we'll put this up there for you, and we'll do a distance. We'll go from here to here. Okay, that is point. Well, you tell me, what is this point? You tell me, Gigi, what is this point here?
0, 3.
Correct. What is this point, Gigi? Good. 4, 6. Find me using the distance formula. You can write it down. Write down the distance formula, right? D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Do you have to choose this point here to be point 1 and this to be point 2? No, you don't. You could switch that around and it would be just fine. Anyway, since that's true, we'll do it though. What is the distance formula? So distance equals, okay, what is x2?
4.
4. What is minus, what is x1?
0.
0 squared plus, what is y2?
6.
6 minus, what is y1? 3 squared. So distance equals 4 minus 0, so what is 4 squared? 16. 6 minus 3 is 3. What is 3 squared?
9.
Plus 9 is distance equals, the square root of 25. What is the square root of 25? What'd you put? Oh, so you had 25 as your answer? Don't forget, this thing's square root the whole time, right? It never ends. That square root symbol never goes away. It stays there the whole time. Okay. There is also a way. Here's something else that they want you to know. I think you guys have that down. There is another, the midpoint formula means this. If I gave you this, we'll say this point right here, and this point right here, okay? This point here and this point here. And I want you to tell me I know that you can see it up here. I mean, you should be able to look at that. I want you to tell me exactly where is the midpoint of this thing. Midpoint as in the exact halfway point. Where is the exact halfway point? Now, you can look at this and see that the point's going to be what? 1, 3. But let's do the formula so we can see if we know how to do the formula. Does that make sense? The midpoint formula also looks ugly. Okay, here it is. You ready? Here, let me show you what the midpoint formula is. It's actually very easy. It's a coordinate. It's a giant coordinate. And it goes y2 minus y1. Isn't that right?
No, it's x1 plus x2.
Oh, is it x2? Am I wrong? Where's the midpoint formula? Boom. Oh, easy then. Okay. x2 plus x1, or x1 plus x2 over y, no, over 2. Right, because this is the x, right? I remember now. And then y1 plus y2 divided by 2. You see how that's just one, that's a coordinate? Yeah. So that's easy. So then let's plug this in. M equals, okay, let's actually figure out, what is this point right here?
Negative
1, 2. And this point here is 3, 4. Okay. Let's plug it in. This will be point 1. This will be point 2. X1. Negative 1 plus, what is x2? 3 divided by 2, comma. And then what is y1?
2.
Y1 is 2 minus, plus 4 divided by 2. M equals, what is negative 1 plus 3? 2. What is 2 over 2? 1. And then what is 2 plus 4? 6 divided by 2? 3. Do you remember what we decided this point was? That it's 1, 3.
That's just like a longer version.
It's not a longer version. There's no other way to do the midpoint. No, look. I mean, you're saying longer version. What are you talking about? I mean, like, right. But what if you can't? Here, we'll do it from here to here. Can you really tell me the exact midpoint? You know what I'm saying? Like, no. So you need to know the formula. Let's do another one. You guys try this one. See if you have it. We're going to go here. And right here. This is point -2, -3. And this is point 4, -1. I want the midpoint. Okay? I want the midpoint. Using the midpoint formula. I don't want you to guess it. I want you to use the midpoint formula right now. Okay, so without doing anything, let's do the midpoint formula. M equals, and then it's just one giant set of coordinates, right? It goes x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So then M equals, what is x1?
2,
-2 plus
4.
4, oops, divided by 2. And then what is y1?
-3
Plus,
-1.
plus a -1, right? That's important. Divided by 2, right? So then here's the deal. You look at this and go, wait a second, a plus and a minus means minus. So you just got to remember that. -2 plus 4 is 2. 2 divided by 2 is 1. M equals 1. And then -3 minus 1 is -4. -4 divided by 2? -2. 1, -2. Let's look at that's true. 1, -2. Does that thing look like it's exactly halfway between them? Does that make sense? Make sense? This is not a difficult concept. Enjoy the formulas. They've been handed to you, and so you just have to do the math. Okay, you guys want to get started? One thing that they do, look at number 8. Right, it'll say find the perimeter of each figure. So is that difficult? What would you use? You'd have to use the distance formula for each of those, right? Does that make sense? For each side, and then you add up the sides, and that's the perimeter. What's perimeter mean again? Right? What does perimeter mean?
How much fence you need?
How much fence? How much the outside edge, right? So you have to each side. So then just add up each side. You're good.
Wait, so you find the points of
You do whatever. You do you. I've given you the tools now to figure out how to do the distance around. Does that make sense? I've given you the tools. Okay, your homework. Two more days, then we have vacation. Page 595, 1 through 10, all. There we go.